Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 28, 2025, just yesterday. This paper provides a comprehensive overview of how pre-trained language models have become the central driving force in creating powerful, general-purpose text embeddings. The paper is titled, On the Role of Pre-trained Language Models in General-Purpose Text Embeddings, a Survey. And it really clarifies how these models have pushed the whole field forward into new areas like multilingual and even multimodal understanding. The authors survey how these models are used for everything from embedding extraction to synthesizing their own training data. And it seems the research community agrees. The reaction online has been really positive, with people welcoming this as a much-needed and very thorough 45-page literature review. Posts are highlighting its broad coverage of models, datasets, and training methods, as well as its focus on innovations like multilingual support and where the field could be headed next. It's clearly being seen as a valuable new resource for anyone working in this space. So, to really get into the mechanics, the authors provide this great diagram of the typical architecture for these general-purpose text embeddings. It's what's known as a bi-encoder architecture, processing two pieces of text in parallel. Each text goes through a transformer, and then a pooling step condenses the output into a single vector. The whole system is then trained using contrastive learning. This is a clever method that teaches the model to pull similar texts closer together in its representation space, while pushing dissimilar ones farther apart, which is key for understanding semantic meaning. Now, for that contrastive learning to work well, the model needs a huge amount of diverse data, and this table gives us a great look at the kinds of datasets used. It organizes them by quality, from massive lower-quality web-crawl data to high-quality human annotated sets. It also groups them by task, like SS for semantic similarity, SR for semantic retrieval, and SE for tasks like sentiment classification. This variety is really the secret sauce. Training on everything from Reddit comments to curated scientific questions is what makes these embeddings so robust and versatile. Building on that, this table really drives home the sheer diversity in this field. It lists a huge range of representative models, showing what pre-trained language model they're built on, like BERT or Mistral, their size, and their training strategy. Many use multi-stage training, which is a step-by-step process. And while most use contrastive learning, many add other objectives like Matryoshka representation learning. This is a clever way to create hierarchical embeddings with different levels of detail. The whole table just highlights the rapid innovation and the different strategies being explored. And this next figure really visualizes the impact of those different model choices. It plots model performance against parameter size, basically how well a model does versus how big it is. Performance is measured on the Massive Text Embedding Benchmark, which is a standard test suite for these models. The overall trend is clear. Bigger models generally perform better. We see decoder-based models like QN and Mistral at the top right, achieving the best scores, but they are also the largest, often needing billions of parameters to beat the more efficient, smaller encoder models. And the role of these pre-trained language models extends far beyond just text. This table highlights the move into multimodal embedding, which is all about combining text with other data, like images and video. It shows a clear evolution. Early models, listed as individual encoders, use separate components for text and images, but the more recent models, listed under Unified Encoder, use a single, powerful base model like LLAVA or QNVL to process everything together. This shift toward unified systems really demonstrates how PLMs are enabling a much deeper fusion of different data types. So to bring this all together, the key takeaway is that pre-trained language models are the core engine driving the evolution of these text embeddings. We've seen how they've shaped everything from the training data and model architectures to enabling new frontiers like multimodal understanding. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.